We are going to watch this simulator to see how different materials act as conductors and insulators. So this experiment is set up that we have this hot water. It is 70 degrees Celsius. The air outside in the room is 18 degrees Celsius. So we're going to see how long it is going to take for the air and the water to reach thermal equilibrium and for all of the hot to transfer to the cold. So we're going to start with no material around our beaker, and let's see how long that takes. So you can see it's dropping pretty quickly. So we're already down to 30 degrees and 18 degrees. So it took just about 10 minutes, and that water was able to transfer all of its energy. So now we're going to add some different materials. So we have polystyrene, which you might know as styrofoam. We have cardboard, and we have metal foil. So let's start with this metal foil. We're going to reset our temperature, and we are going to put that foil around the beaker and see how long it takes this time. So we've started, it's already dropped down to 60. So it's dropping 5 degrees pretty quickly, and 19. It's taken a little longer for that last one there, so it took about 16 and a half minutes. So a little longer than if just there was no material around the beaker, but not a lot longer. Okay, now let's go ahead and we'll try this styrofoam. So the styrofoam, we've started. So it's not dropping quite as fast as the cardboard, but still going down pretty quickly till about 45 here. Now it's going to start slowing down. So you can see at the beginning, right, we could count with it. It was going down 67, 66, 65, just a nice counting pace. And now it's slowing down a lot more because the room temperature and the water temperature are getting closer. So it's harder for the water to transfer its energy to the air. So we're over here at about 50 minutes and it still has not reached equilibrium. Getting closer. 1 more degree. There we go. So that one almost took an entire hour for those to reach thermal equilibrium when it was wrapped in styrofoam. So we have one last material to test out is the cardboard. So let's see what happens when we have that cardboard on there. So it's already dropped, right? Those first 10 degrees go pretty quickly because there's such a difference between the hot water and the air. As it gets closer, it's going to slow down. So we're here at 26. So we've passed the tin foil. We're not up to the styrofoam yet though. So we can see that the ones that cool down faster are going to be better conductors and allow that heat to transfer through. And almost to the 18. Ooh, that last degree took a while. So those materials that are allowing the heat to transfer through are going to be better conductors, and the ones that allow the heat to remain in there and trap it in there are going to be better insulators. So now there is a table on your next slide you can look at that is going to show you all of the temperatures taken every 10 minutes that you are going to use to answer some questions.